Hello students, today I will teach you chapter 13, limits chapter. Students, today I continue our exercise 13.1 to related our rules for the limits, working rule, one of the plus, one of the minus, product and divide related. So in the first question, limit x tends to 3, x plus 3. I just apply to limit x tends to 3, one of the x, plus limit x tends to 3, it is 3. By working rule of limit, and very easy students, you will apply that. Here putting down your x place is 3 and constant have as it is. Now similarly, question number 2, limit your second questions x tends to pi, x minus 22 by 7. Yes students, x minus 22 by 7. Similarly going, limits apply to working rule, x tends to pi with x, and here limit x tends to pi with 22 by 7. Just write down by working rule of limits. Here I operate addition working rule, and that apply I subtraction. Only 4 working rule are there. So my answer is here pi and constant having as it is. Now question 3, limits to third questions, r tends to 1, pi r square. Very easy students, here product rule but constant pi, so I just apply limit x tends to 1, r tends to 1 is pi, and in multiply limit x tends to 1 r square, and apply in place of r only 1, constant pi as it is. So pi as it is, and here 1 square by working rule of limits, and indirectly your answer is only and only pi. Now question 4. Fourth also very easy, limit x tends to 4, and the function is that 2 given 4x plus 3 by upon given x minus 2. So students, here first of all check denominator after putting limits, always it is non-zero, then you apply the working rule. 4 minus 2, it is non-zero, so I apply limit x tends to 4, 4x plus 3, same here, it is x minus 2. Because our x minus 2 denominator is never 0, now apply by working rule of limits. Simple apply to powerity, 4 with 4 plus 3. Here 4 minus 2. It means my answer is a 16 plus 3 by 2. It should be just only 19 by 2. And that's your simple answer to your question 1 to 4. Students, you are happily done. Now students, continue. Are we going ahead? Question number 5. It means working rule related our questions given in the limits parts. It's very easy parts. Now fifth one, question number 5, find the limits of the function limit x tends to minus 1, and question is there x raised to 10, x raised to 5 plus 1 below x minus 1. Just you putting down your limits in the denominator and check it is 0 or never 0. Minus 1 apply here, definitely it is never 0. So I just go to working rule, limit x tends to minus 1, x raised to 10, x raised to 5 plus 1 upon same as students x minus 1, and mention here by working rule of limits. Now very easy and simple, putting value in place of x, minus 1 raised to 10, minus 1 raised to 5, and here minus 1 to minus 1. Now minus 1 to 10 is 1, here minus 1, and that should be minus 2. Indirectly this cancel, my answer is only and only minus half. Now continue, question number 6. Yes, 6 is the IMP questions. Exam oriented question number 6. X tends to 0, limit, and question is x plus 1 raised to 5 minus 1 upon x. Yes students, here if you put in your limits in place of x, definitely denominator is 0, so we can't apply the limit putting first. So in x plus 1 I assumption, suppose x plus 1 is equal to suggestion just like a t, so your x become t minus 1. This x students I will apply to here and take apply, simple, your limit changing. Your original limit is x tends to 0. If x tends to 0, then t tends to x plus 1. It is a 0 plus 1. I mean t tends to only 1. So your limit t tends to 1, it is t raised to 5 minus 1. And what is the x? T minus 1. And this formula already I explained in the previous part students. Formula is that limit x tends to a, x raised to n, a raised to n by x minus a, and is equal to answer n a raised to n minus 1. So same you take here a raised to 1 raised to 5. And that parts you just check out that a is 1, n is 5. So my answer is 5. 1 raised to 5 minus 1. Indirectly it is 1 into 5. Your overall answers only and only students just like a 5. Now continue question number 7. Very easy numerical. 7th also. Now big question, let's start. Limit x tends to 2, 3x square minus x minus 10 by x square minus 4. Students, here you check your denominator is 0 if you put a direct limit in place of x. Numerator also 0 because here 4 3 is 12 and here 12. It means after putting limits it is a 0 by 0 form. So we can't apply direct limit. So I go to splitting, simple. So limit x tends to 2, 3x square. 3 tens are 30, but I want to minus 1. It means 5, 6. So minus 5x plus 6x. Minus 1 carry, so this plus and that minus. 6 5s are 30 and 10 3s are 30. So denominator also x plus 2 and x minus 2. Now you will take two common values. So my first common, limit x tends to 2, here x, 3x plus 5. That is only 2 common, 3x plus 5. And in the last value x plus 2, x minus 2. Now after students common taking factorizations, you must be cancel x minus 2 numerator and denominator. So you have to only limit x tends to 2, that is x minus 2, 3x plus 5, and the same is. Now students check this factor is cancel and that's to coming by 0 forming. It's done, gone. Now you check denominator is never 0 if you put the limits. So I just going my working rule, denominator and numerator both have, I just put it the working rule by working rule of the limits. Now easily you can put your limits 3 into 2 plus 5, here 2 plus 2, indirectly 3 2s are 6 plus 5 11, and downwards 2 and 2 4. Very easy. The solution is students done here. Now continue question number 8. It also very easy. Limit x tends to 0, x tends to 3 and x raised to 4 minus 81 by 2x square minus 5x minus 3. This also students tick mark in the IMP list. Here also you check denominator and numerator. If you putting limit 3 raised to 4 81 and minus 81, it's 0 by 0. So here definitely it's 0 by 0 form. So you can't put the limits. So go to factorizations. Very easy. I just make the factor for denominator. 3 2s are 6, but I want to 5. So just apply the splitting. Yes, 2x square. If you take here 2 and 3, it is possible. 2 into minus 3, it is minus 6. But I want to minus 5. So it is possible 2 and minus 3 taking both minus 2 minus 3. No, it's not possible. Minus 5 coming. But I want to minus 6. So here making to splitting 6 ones are. It's best way. Minus 6 plus 1. That cover to also 6 ones are minus 6 product and minus 6 plus 1 is minus 5. This splitting method I will apply here students. So minus 6x plus 1x minus 3. So indirectly you have to one factor easily coming. 2 common, x also. So x minus 3 and minus plus 1 common, again x minus 3. So simple way you will take the factorizations. One of the x raised to 4 minus 81, another x minus 3 and one of the 2x plus 1. So does this I will take a unique forming of formula x raised to n minus a raised to n by x minus a related. So apply here in factor form x raised to 4, 3 raised to 4 by x minus 3. 3 raised to 4 is 81 and this limits I will show two separately, 1 by 2x plus 1 by working rule of limits. This is the main steps. Now this formula students you know very well. Yes, this formula. I just write down the formula. Limit x tends to n, x tends to a, x raised to n, a raised to n, x minus a, it is n a raised to n minus 1. Just apply. 4 power it is n and 3 is your a. So my answer is 4 into 3 raised to 4 minus 1. Yes, 4 is n, a is 3 raised to 4 minus 1 and here apply the limits. 2 into 3 plus 1 and that should be your easily answer. So here answer is students 4, that become 3 raised to 3 and here 3 to the 6 plus 1 7. Indirectly 4 into 3 raised to 3 is 27. So 4 into 27 by 7 and 27 2s are 54. 2s are 108 by 7. Either product take 4 7s are 28, 2 carry 10, 4 2s are 8. Yes, that's easily your this answer for IMP's numerical done. Now continue question number 9. Very easy. 9 is a very short numerical students. Limit x tends to 0. Question is ax plus b upon cx plus 1. Just apply denominator parts 0 or never 0 after putting limits, checking c into 0 plus 1 non-zero. So direct go to our working rule. So limit x tends to 0, 1 of the ax plus b upon limit x tends to 0 cx plus 1 by working rule of limits. Very easy. Now putting the limits, a in x place of 0, similarly c 0 plus 1. So indirectly my answer is only and only b. Yes students, here 9 numerical done. Very easy. So I go to now 10th one. Yes, 10 also. In the same pattern, limits asking for about questions. Z raised to 1 by 3. Limit z tends to 1 by 3 minus 1 and 1 by 6 minus 1. Students, here power it is given. So I will apply this formula first. First of all, you think about this formula in your mind. Limit x tends to a, x raised to n, a raised to n by x minus a. N is a 1 by 3 either. Maybe it's 1 by 6. Formula is that n a raised to n minus 1. So here I first of all do z tends to 1 given, that's why I will take divide each term z minus 1. Here also divide z minus 1. If you operate this formula, check here, x minus a division given. If you x tends to a given, same here I divide z minus 1. Now working rule. So limit z tends to 1 raised to 1 by 3, 1 raised to 1 by 3 upon z minus 1. Same, limit z tends to 1, z raised to 1 by 6, 1 raised to 1 by 6 by z minus 1. Check students, here in this formula you operate, n become 1/3. If you this operate, then n become 1 by 6. So my answer is done, 1 by 3. 1 raised to 1 by 3 raised to minus 1. Same here, 1 by 6. This property I operate. Now 1 raised to anything, it is 1 only. So my answer is 1 by 3 into 1. 1 by 6 into 1. So 1 upon 3 into 6 upon 1. Numerator, denominator. Denominator, numerator. Your answer is only 6 by 3. Indirectly 2. Yes, that's the short and sweet answer. Students, here done. Continue. Question number 11th. 11th also in the same way we going. Question, limit x tends to 1 ax square bx plus c upon cx square bx plus a, and conditions are there, a plus b plus c never 0. Very easy. Never 0 means you after putting value for the limits, this part is never 0. So you can go to easily your working rule. So here apply working rule. Limit x tends to 1 and the value is that very easy, ax square bx plus c. Downward also same as I write down, cx square bx plus a, and mention there by working rule of limits. Now students, you putting your limits in place of x, exactly 1. Yes, so here a 1 square b1, similarly c1 square b1, you getting a plus b plus c, c plus b plus a. Now this both cancel because it is never 0. So your answer is only and only 1. Yes, now continue. Question number 12. 12th also very simple and easy question given. Limit x tends to, yes, my x tends to minus 2 given. Question number 12. And the function is 1 upon x plus 1 upon 2 upon x plus 2. Simple, you take students, denominator 0 form or non-zero form after putting my limits. Yes, if you operate x tends to minus 2, definitely it is 0. I can't put in that. It means this answer is 0 by 0 form. Yes, so I just converting my take the LCM form. Limit x tends to minus 2. Here 2 plus x by 2x, and that same is, students, indirectly 2 plus x and x plus 2, both of the cancel. Only you have to remaining your data, and here put down limit in place of x minus 2. So my answer is done. 2 into minus 2, it is 1 by 4, but minus. That's a simple answer. Now students, we going ahead new questions for the trigonometric related. Our limits define. Yes, now 13 questions running to trigonometric related. Your questions. Limit x tends to 0, sine of ax below bx. Yes, very easy. First of all, you check for the sine part. What is the coefficient of x only, students? Coefficient of x. Here check. That is the coefficient of x is a. And I use this formula. First of all, you think about this formula in your mind. Sin x by x is 1. Here coefficient x is a 1 only, but in this case a. So I just a balance on it. Limit x tends to 0. Sin ax by a into a. Extra a multiply and divided. Other, look at that, x is same as, and this b I just write down here. A cancel and bx is same. This part I will cover to this balancing using this formula. Limit x tends to 0. Sin ax by x, and constant you will take separately, and this is your check. A also multiply here, that also multiply. A into 0, it is 0. My answer is 1 into a by b. Indirectly your data is done a by b, and this property I use here in place of that, and easily you will define your answer. Continue. Question number 14. Limit. Same way, same calculations given. X tends to 0. Sin ax upon sin bx. But condition given ab never 0. So does here a coefficient, second time b coefficients. Both I will manage. See here, I just managing to coefficient only. Sin x by a into a. Sin bx by b into b. Only you first think here in your mind what is the coefficients given to sine or related x. Here a balance, b balance. Now x extra balancing in the both term. This cover and this cover, if you use this formula, it is 1 only. So I will write down limit sin ax by x into b separate, I mean into a separate. Here also a write down, same as limit bx tends to 0, sin bx by bx, and this b is separately. This are one part, this are second part. So does if you written here b multiply, that also multiply. B into 0, it is the 0, same as here a into 0. My answer is here 1 into a, and formula write down limit x tends to 0. Sin x by x is universally 1. So your answer is only a by b, and that's the student simple way your answer is done. Now continue. Question number 15. 15 is the IMP questions. Very the most IMP for exam level. Yes, in the final exam related questions. Question number 15. Limit x tends to pi sin pi minus x upon pi minus x. Sin pi minus x, pi minus x. First of all, you check your limit is 0 given or not. Whenever you operate the trigonometric related formula, maybe sin either 10, your data for limit must be 0. Then you operate this formula. So here students, limit is 0 not given. I will translate in the limit 0. So depend on these terms. Suppose x minus pi is equal to t assumption. So x become pi plus t. You can't suppose for related this one. Always suppose by that one. So limit changing. If x tends to pi, then t tends to x minus pi. It is pi minus pi. T tends to 0. Very easy. Limit converting 0. So your data is limit t tends to 0 sin pi minus, what is the x? X is your pi plus t. Same here, pi minus x is what? Pi plus t. You easily operate this rule and get the answer. So students, my limit t tends to 0. Here sin pi minus t. The same pi minus t. This cancel. Same as this cancel. Only I have limit t tends to 0 sine of minus t. Now students, sine internal minus, it is an odd function. It means minus common carry outside. That is your odd function. That's why we will show minus carry outside, minus sin t, pi with minus t. This minus and this minus students only cancel. Other I will show pi is constant outside and limit t tends to 0 sin t by t. And that is your original functions. Here defined, answer is 1. So 1 upon pi into 1, my answer is 1 upon pi. And that the students easily, your question number 15 students here done. Now students, here up to 15 ending I will stop this video, and further explanations for this related limit chapter students I will explain you in the next part. Bye bye.